All right, thank you for joining us for our second session today. We have Mike Wamachol. He has had 15 years experience in the gas industry. He started with Lynn Weld in Denver as a route driver. He has 20 years experience in the welding industry, 5 as a welder, and he's taught for Lincoln College of Technology in Denver and was an adjunct instructor for MATC and KSU Agricultural Education. And currently he's an outside sales representative for Matheson.
Thank you. Thanks for the invite. Appreciate it. Got a lot of good information here. Like I said, I am Mike Wamachol. I've been with Matheson for roughly 15 years now. 4 years out in Denver, going on 11 years here in Manhattan. Industry wise, I've been around for quite a while. Rachel reached out a while back and was looking for looking for us to do some sort of presentation on safety because conversations we had about on campus. And so I threw something together. I'm a little out of my comfort zone. I'm a sales rep. I'm used to talking face to face with a couple people, not a room full of people. So bear with me here. I might move too fast. I apologize, but so we'll go ahead and get her moving here. I realized as I was putting this presentation together that I hadn't done any sort of PowerPoint presentation since I was in college. So I've almost forgotten how to use the program. So that way to the normal one that feedback. Well, our friends at OSHA. Breath gas can be toxic, oxidizing, corrosive, or inert. Leakage of any of these gases can be hazardous. Leaking inert gases can quickly displace air in a large area, creating oxygen-deficient atmosphere. Toxic gases can create poisonous atmospheres and flammable. Oxygen or reactive gases can result in fire and exploding cylinders. In addition, there are hazards from the pressure of the gas and the physical weight of the cylinder. A gas cylinder falling over can break containers and crush feet. The gas cylinder itself can become a missile if the cylinder valve is broken off. Very, very true. I have some video examples of cylinders falling over we can look at here. Pulled them off of YouTube. Also down below, all cylinders, whether empty or full, must be stored upright. Secure cylinders of compressed gases should be never dropped or allowed to strike each other with force. Transport gas cylinders with protective caps in place. Do not roll or drag cylinders. Don't roll the cylinders unless you're a professional. Cylinder itself is a one piece. Piece here, this is formed from one single plate of steel, solid, roughly 3/8 of an inch thick. The valve and the threads, valve screwed in, the thread is pressed on, and that's what forms our cylinder. Different cylinders have different thicknesses. Higher pressure cylinders, this is the 2400 PSI cylinder. We have some that are 6000 PSI, and those are roughly that thick. They weigh same way. One of these cylinders is around 90 to 100 pounds itself. So you can tell when you're moving one, you can tell the weight. So cylinder cap's one piece. Cylinder caps are not all the same. We have different threads on each of these caps. Some of them are coarse, some of them are fine. This actually has a little bit of technology in it. They're designed to fall directly straight down 6 foot direct drop. And I have tested the theory myself. I was training a new driver. I'm gonna tell you a lot of personal stories because a lot of personal stories is good for you guys to hear. It'd be scary, but it's good for you guys to hear. I was training a new driver when I was on the route out in Denver, and it was like his second day. He didn't really know what he was messing. And I pulled up to my first stop. I was on a little bit of an incline, which if you're a pro, you can manage just fine. And pulled in, I said, all right, come up on the back of the truck with me. Let's observe how we move cylinders, how we strap and everything like that. I said, don't touch anything, please. Just watch. So I was going in one bay, I pulled the cylinder out and I rested against the side of the truck on the incline and went to another bay, got another cylinder out, strapped the other bay to back up. And was strapping the last bay up. And I heard and the other cylinder, which was the piece of the cylinder, had fallen off the back of the truck, falling directly onto the cap, and the cylinder was rolling away. The customer was standing over here, and he was going crazy. Like the new guy had no clue what he was doing, but the cylinder took a direct fall right onto the cap, pushed the cap down, and the cap split all the way up the side here, and the cylinder was just rolling away. So we don't move cylinders without caps on them. Yeah, so that's just the first story. Deck labels. When you see one of our, you guys mainly use lab grade gases here, you use some industrials. We've got a number of labels on here, barcodes. If you look at these labels, it will tell you what's in the bottle. Okay, don't go by the color of the bottle. We stopped doing the color of the bottle a long time ago. We have our DOT label. This is the most important label on the bottle. If this label is not on the bottle, we cannot take the cylinder. It will not take the cylinder unless we go back to our store and get a label on it, and we can identify the cylinder by what was in the cylinder, how we track what's in the cylinders by these barcodes. So if this DOT label, someone peels it off, you're going to be in a world of hurt until we can get the correct label on it. This example is ultra high purity nitrogen. We have it when it's filled, it's labeled with a barcode and a lot number. We trace all our gases. So if it's a UHP helium or a dry helium or dry nitrogen, we can trace it back to when it was filled, the lot number, what gas we used that came out of our bulk tanks in Waverly. And that's how we track them. So we've got a DOT label, we've got on a lab grade cylinder, we've got a lot number, and then we have our barcode, which is how we track. So you've had this cylinder for 365 days. That's how we track rent. That's how we track everything. So this, please do not touch any of these shoulder decals. They all serve a purpose, and by far this one's the most important. This one will show nitrogen. It won't show anything, other characteristics. If it's a two-part gas, chances are if it's like a nitrogen and CO2 and has like 2% helium in it, it's only going to show two of those gases on this DOT label. So very important that we don't touch these, just leave them alone. Stamps. The safety and the CGA valves, I'm going to go to the next slide. We can look at those. Okay, so laser pointer. So DOT markings, test dates, serial numbers, manufactured hydrostatic test dates. Every cylinder that you have, whether it be just a 50-pound CO2 all the way up to a lab grade cylinder, has stamps on it. DOT is DOT, Department of Transportation. They are the ones that mandate all policies with handling cylinders. Metal type, working pressure. Working pressure, that's that's 2,250 PSI. Some of these cylinders, like I said, we have up to 6,000 PSI cylinders, which are, that's a lot of pressure. This one is rated for 2,400. Some of these cylinders, we can fill 10% over their rated pressure capacity based off of the hydro test results that we give them. So where we find that is, there's your serial number. We used to track by serial number. We still do. When we input our cylinders into our track about program, we use the barcode, and then we also enter in the serial number off the cylinder so we can track it. This cylinder is 6232553Y, usually 7 or 8 digits. This also has a test date. There's your month and your year. The plus means we can fill it 10% over its rated capacity, and the star means we can get an extra 5 years before we need to hydro test again. So most cylinders, except for maybe a fuel gas cylinder, like an acetylene cylinder or a propylene cylinder, they have a 5-year test stamp. Old CO2 cylinders, some of the oldest cylinders you'll ever see are 50-pound cylinders, and I think the oldest ones I've ever seen come from 1896, somewhere around there. They are old. They fail hydro tests. They aren't filled with pressure. They're filled with liquid CO2, so there's no real pressure inside of them. But most of your T cylinders are going to have a 10-year test date, and if they fail hydro test after 10 years, they're generally pulled from the population and recycled. There's also our DOT, or not DOT, but another barcode of how we track our cylinders. The valve itself on these cylinders, the valves are all brass. All brass. The only time you'll see when we screw into the actual cylinder, that's the only time we will ever use tape. It's the only time we ever use tape. Does anybody have a reason why we don't use tape on anything else?
You have to use tape, it means something not sealing properly.
Correct. Correct. Brass is super soft. Super soft. And believe it or not, we can oval these valves out. They can A shape by over tightening or basically over tightening. And they will leak past your regulator. So it's a pretty good heavy piece of brass. So no tape ever on any brass fittings, whether it be a bottle or any type of hose running with brass fittings. On the back side of the valve, we've got you see it up here better. Got safeties right here. That's actually a burst foil safety. So if we were to pull this off, they have different ratings. This one's a 2,400 with a 10% over. So this is probably a 3,000 PSI safety on the backside, if not more. Like I can't remember the without doing the numbers. So there's you pop them loose. These are on here in case just a safety. If something ever happens where that oil blows out, this is, we're releasing gas out of here out of a 1/4 inch port versus a 1 inch port. And if the cylinder is not supported, most likely it's not going to blow over or fall over, or if it is, it's not going to be near as loud. So it's there to protect you. So these are replaceable. They do go bad. They are checked every time they're filled. When we do a hydro test, after the test is after we come to the end of our test date, I have the one here. hydro test was what we call when we send the cylinder back off to get a new test date stamped into it. Take the cylinder, we remove the cap, clean it, give it a visual inspection on the inside. We have a special light that we use to look down, and they'll grade it. They'll take a special fitting, screw the fitting into it, or put it on a hoist, lift it up. We'll drop it down into a pressure tube. Drop it down in. We have a cap that goes over the top. We have hydraulic clamps that come over and clamp in place and hold the lid on. And we'll clamp that, and we'll run this up to, this runs up to roughly 3,700 PSI. And we hold it there for 3 minutes. And if there's any kind of drop, it's based off that grade. The grade is based off the drop, which generally, if the cylinder is good, it holds pressure. And no issues. Comes out, re-stamped, sent back to fill, and back out into population. So, yeah, so what I've got here are some examples of cylinders falling over, shearing the valves off. I don't know if a lot of you are familiar with Mythbusters. They did an experiment. Yeah, it's a little wild.
Of 20 years, almost 100 cubic feet of atmosphere, about
It's just the one video. That's just a simulation. That's not the real thing, so. Someone once told me, and I've never have done the research into it, that when someone shears a bottle off one of these larger cylinders, it has enough thrust, or it has the equivalent of thrust of the old Apollo rockets. It doesn't have a volume, but. Control board.
Skip the screen.
Okay. This is a good one. You know, it's not just the gas that the bottle, the damage the bottle does. It's all that gas that just released in there, whether it be nitrogen or CO2 or helium. It's the damage the bottle's doing, but I mean, if there's someone in that facility and you're in a confined area, all that gas just got released into the, I mean, you're at risk of asphyxiation. And that's another thing that, you know, we don't really think about as people who are using or in these labs or areas where you're using these bottles is if the bottles, you know, left on and the regulator's hooked up, and it's left on overnight. And we talked about that valve leveling out. You know, we're at risk of filling our lab full of gas overnight. And I have a couple examples. He can tell you about one that happened here in town. I can tell you about one that happened at Matheson out in Denver. We had a CO2 cylinder burst at safety. Here's the Mythbusters one I'll come back to. See, he's laughing and cheering about it. He's an idiot. I don't really find it funny. I mean, it's great for experimental purposes just to make yourself aware of what you're dealing with. But this is no joke, the damage it does here. And he's still laughing. Hollywood. So we punched through the first wall. We almost punched through the second wall. And then we completely moved that makeshift wall back a half an inch. With just a one cylinder. So. Biggest thing is, when it comes to handling these cylinders, and we talk about this at Matheson all the time, because we are a very safety oriented company. You can ask the driver with this, very safety. Biggest thing, one of the biggest things we talk about is complacency. I'm sure everybody knows what that meaning is. We deal with these cylinders every day. We deliver hundreds of these things every day. And our guys are out twisting and moving cylinders. And we just get numb to it. We get numb to working with them on a daily basis. And yes, we do have cylinders fall over, and yes, it happens. And you can hear it throughout our whole facility. I'm sure you guys may have seen somebody knock a cylinder over and had a valve come off. But I found the biggest thing when it comes to handling cylinders, working with these cylinders, is to avoid complacency at all costs, because it will come back and bite you. Another example, a couple examples I've had working with the acetylene bottles. My background is I'm a certified welder. I started welding when I was 19, 20 years old, and I still weld in my home shop. I lived down in Texas for about 4 years, and I've worked in the oil field and manufacturing, and I worked in job shops. One job shop in particular, we had a young kid. I think when I was a young kid. We had a gentleman who didn't really know what he was messing with, and he was using a tractor to put the acetylene, and the bottle emptied out on him. Well, he was under the understanding that acetylene wasn't flammable. Yeah. So, yeah, I know, but he assumed the oxidizer of the oxygen was what was going to get you, which it will. Makes things a little bit worse. And he put the cap back on the cylinder, but left the valve all the way open. And there's still residual in there. There's still acetone inside that cylinder. And he rolled it over next to my workstation while I was grinding on some handrail, didn't see it. And caught it out of the corner of my eye. Well, I caught it out of the corner of my eye as I caught it on fire. And I ran over there. I had my welding gun and my bibs and my gloves, and I ran over there, spun the cap off and shut the valve off. Yeah. And it still scares me to this day, even more than I know when I'm really dealing with there, because like, really, should I have done that? Acetylene has burst plugs on the top of the cylinders that melt if there's a fire and release out the top, so it's not gonna blow up, thank God. But yeah, so I had to politely explain to the guy, this gentleman, what he'd done wrong. Another time, this one was my fault. I was welding in my own shop. I had my torch out. I got a cylinder that had a valve that was egg shaped. And I got it from where I worked, this plug weld out in Denver. And I was just using my own thing. I look over and hear this voice come from my cylinders. I'm looking over it, flaming out the valve. Yeah. I had an oval out cylinder. So yeah, so I shut the valve off real quick. I'm done. But it happens more in the industrial side, not necessarily the laboratory side. I think the laboratory side we need to focus on.
So in university also it had somewhere in Texas. This is with liquid nitrogen. But the story is a little bit awkward here. So as you have shown the video there, when the cap is gone, so the plume of the gas this direction and the cylinder other direction, that makes sense because it is action is equal to reaction. That is the rocket principle, right? But what is their incident is the gas, high pressure gas was able to shoot the ceiling. So what could be the situation? Is there any possibility, like we have already fence there and bottle is secured? Is there any possibility that cap would be off? That is what I'm thinking what had happened. The cylinder was standing, right? And all of a sudden the cap gone. So that way only it is possible to shoot vertically up or down. I don't know, that was intentional experiment or what could be the foreign element that hits that cap on the standing cylinder.
That's very interesting. But when I've laid cylinders over. I mean, when he was on the truck too, he was on the truck for probably longer than I was. We can tell you incidents where he, rolling caps on, you got a cap on it, you're probably not going to do any damage if you knock it over. I used to teach my students, I would literally scare them. I taught for KSU Ag Ed and MATC, and I through a safety class where I always had the philosophy that I was gonna scare the crap out of you and make you realize what you're working with, but then I was gonna build you back up and get your confidence back there where it was nothing, where it wasn't a big deal, where the only thing you need to worry about was complacency. So I would take a cylinder that I knew was empty all the time. I knew it was empty. I personally checked it, and I would just pull it out and just set it in the middle of the crowd, and maybe in a circle. And I just kick it over. Whoa, they forget. Nothing ever happens. Nothing ever happens to the cap. I mean, you've really got to drop it on its head to really impact the cap. So if the cap is on, I'm not going to worry about anything. I'm not going to worry about shearing a valve off at all. I mean, there is that possibility, but that's not something I would definitely worry about. I think in the lab, we need to worry about how we handle the cylinders, make sure the cap's on them, make sure they're on the cart, make sure that they're chained on the cart. Make sure we're wearing the proper PPE, and I'll go over all that. We need to worry about if that cylinder is not tied to any sort of wall or the lab table it's next to, that cap is on and there's no regulator attached to it. we need to worry about. How many of these labs have O2 sensors on them? How many of you guys have O2 sensors in your labs? Anybody, any other idea?
I recommend them, but most don't currently have them.
O2 sensors are something guys should really think about. If you have a cylinder that blows out overnight or leaks out overnight and fills your room full of gas, obviously it's gonna displace all that air. And I told you to get back to it, but we're back to it. A couple examples of asphyxiation. I don't know, recently they did, was it Georgia? They decided to do an execution with nitrogen.
Alabama.
Alabama. I don't know if you've heard that or not, that's kind of controversial, but yeah, so, we had a CO2 cylinder, which CO2 cylinders are filled by liquid, they can store quite a bit more, gas in them, because you get liquid in, you're getting a lot more gas out. We had a CO2 cylinder blow off in a facility, in our Matheson facility out in Denver, and it blew off overnight. And we had a guy come in about 6:30 the next morning, and he went down. He walked into the facility and he went down part of the facility where it happened. And the next guy went in behind him, he went down too. And luckily we got them out in time, but this was a facility probably double the size of this room. So was it Cox Brothers?
Koch brothers, we had, it wasn't on our side luckily, but one of the Pepsi pumps failed, and it pumped one of those out in the basement. And the gal went down there, she started feeling bad, got back out, and by the time the fire department got there and everything, her oxygen level was, I want to say at 65 or 70%. So if she wouldn't have got out when she did, then she might not have come out. And so we've got CO2 sensors in about half the restaurants in town now, so that everybody's aware of what's going on.
These are links, and I'll send this presentation to Rachel. These are links where you can go in and get. We sell them on our labs. I gotta do a Matheson plug. I mean, I'm a sales guy. What do you expect? These are all links where you can get wall holders, chains, holders for tables, brackets to roll cylinders into, where you can put 4 or 5 cylinders in, chain them up, bolt them before be safe. Carts, we used to be a facility where we rolled cylinders everywhere. We would roll 2 at a time, we'd roll them anywhere. Since Matheson came over and we've really focused on safety and preventing injuries as much as possible, we no longer roll cylinders more than 15 foot. We use dollies, these drivers. Everybody should be using these chains when moving cylinders. So we get our carts, we sell the carts. We have a newer carts, and I'm getting ready to go over this big guy here. So we are a full line safety PPE company. Anything safety, O2 sensors. We manage all that. So if you ever need anything, feel free to reach out to one of us. So I'm not going to go through and make us go shopping. Regulators. When hooking up a regulator to a cylinder, there's some safety steps that you want to go through before you hook up a regulator, especially if you're messing with an oxygen bottle. The industrials aren't so bad. Sorry, not sorry.
I'll make sure I know where it's going.
Not sorry. First thing I'm gonna do, I'm gonna have these glasses on. I gotta make sure, yes, these are safety glasses. I gotta make sure my cylinder valve is free. Lab cylinders, they started coming with the plugs, but what I'm gonna do, I'm just gonna, real quick, I'm gonna crack it, make sure it's clear. take my regulator, spin my regulator on. Tighten it down with my 7/8 wrench. And then I'm gonna. Back off my CFM CFH PSI valve. Anybody know why we do that? Especially on an oxygen cylinder. Anyone have a regulator blow up on them before? I'm never wrong. So I am at a union shop in downtown Denver, Colorado. The instructor asked me to go around and check all his bottles. Walk around, check all his bottles. I lean around the one bottle. And from behind the loader, I lean around, I look around like that. One of the students came up, opened that bottle up, just cracked it, opened it up, right in my face. I had safety glasses on, but for some reason they blew on the delivery gauge, so I didn't get the full pressure. But just the delivery gauge, blew pieces of plastic into my face and bloodied my face. And I was probably a foot away from the gauge. So yeah, I always preach safety when it comes to turning on a bottle, setting your regulator. I'm gonna screw my regulator on, I'm gonna back the set screw all the way off. So we're not getting pressure through my regulator. And then I'll screw my set screw in to what my delivery pressure needs to be, whether and labs they use pretty low delivery pressure. So when I'm turning on the physical, I'm gonna stand off the side because it's not fun having one blow up in your face. Always stand off to the side, crack it real slow. Don't get too carried away, especially with an oxygen bottle. Anybody heard of heat of recompression? Especially with an oxidizer. If I have an oxygen bottle hooked up to a regulator and there's a chance that my regulator's a little bit dirty or my valve's a little bit dirty and I walk over here and I just turn it on, even if my set screw's all the way back out, just turning on this valve with my regulator and the nipple and the net coming off the regulator, heat of recompression, that pressure is coming into a basically room atmosphere and repressuring back up the heat from that alone. Could cause I don't know, rapid expansion of that guy that, or just basically a little bit of an explosion. So always open your cylinders nice and slow. Heat of recompression is no joke. Cylinders need to be cleaned in labs. Yes, we keep them clean. They have cylinder nets here. We do our best to keep the lab cylinders looking as good as possible. Anytime you see a cylinder that has grease or oil or anything on it, I wouldn't use it. Don't try to clean it. Because even the soaps we usually have oils in them, and oxygen is an oxidizer, and it doesn't take much. We ran an experiment one time. This was off the books. This was not involved with Matheson. We took a paint thinner can that was empty, cut the side out of it, sprayed some WD-40 in it, ran an oxygen hose out to it, set it in the sun, turned the oxygen bottle on, and seconds, just the sunlight lit it off. So that's what an oxidizer can do. So heat of recompression, all that fun stuff, yes.
So these caps are universal, they fit to all cylinders? Or we need to be careful on the caps also?
The caps?
Yeah,
Your cylinder, when you get a delivery, your cylinder, the cap is gonna be correct. The cap will be correct. Usually it's, we deliver 3 or 4 different cylinders to an account and, all of a sudden we're gonna send a bottle back if we're scrambling, so we just grab some cap. Well, this cap right here is a fine thread cap. Some cylinders have a coarse thread cap. So you'll get a cylinder You'll get a cylinder, we'll get a cylinder back, the cap's just barely screwed on. That's not good. You shouldn't haul a cylinder like that, we can't haul a cylinder like that. So it's best to keep a cylinder with the bottle as best you can. Settling bottles actually have a wider cap. So you can't use the settling cap, the settling cap will just sit down on there. All right, big boy. Okay, these are a lot more dangerous, they have a lot more gas. They have roughly 13 of those bottles inside of one of these tanks. Well, you use them, how many guys use them in your labs? Okay, so. Part of the reason we wanted to come down here and do this presentation is because. Well, we just have. Students or some people that just aren't aware of how these cylinders function. And what they do, and we'll get a safety assistant and we'll get a phone call, or Lynn or I'll have to come down to campus. Come down and train. We try to avoid that at all costs. We've had situations where fire department's been called. Had to come on campus, and then the fire department's turned around and called us. We're trying to avoid that as best we can. So, most of the cylinders used on campus are low pressures, so they do hiss a little bit, but I mean, we are putting liquid here, so. Common sizes used on campus are the 160 and 180 liters. Most common pressure used with is 22 PSI. Some of them are on nitrogen, some of us are using 230s. We're using 230 argons. Where's that over in Throckmorton? And everybody else is basically just getting it to pull nitrogen off of it. Safe handling, just get a card.
And I've delivered, like, I think I got 3 or 4 of these up on campus we've donated. Because we want you guys to move them as safe as possible. So.
I'll show you the proper way to do it here real quick. Come on, Phantom. So, if you have a card, bring it in straight. Let's see. Don't leave the hook out. You can see this. There's an eyelet right here. When you have the proper cart, you have to set this hook at the proper height. With it just set up just like that, the hook is going clear to the top of that eyelet on that tank. See that? Slide that hook up underneath. When you bring it down, the tank should not be lifted. The tank should be sitting square on the ground. Go ahead, rock her back. Two hands. These are the most accident. These are the cylinders that get everybody's fingers, okay? Everybody pinches their fingers, and these cylinders, these liquid dewars, you can see 450 to 700 pounds a piece. And we're moving them around on the car. We got to keep our hands clear. So, when we're moving around, if I'm rocking one down, these hands never leave this bar. Never leave this bar. If it's full, foot. Otherwise, you're going to strain. The nitrogens are roughly 450 pounds. The argon are over 700 pounds. But they're not light. So, and my guys, back in the old days, I knew a guy that could roll 2 of these at one time. So. These cylinders aren't going to be any different as far as label goes on the shoulder. I've got my barcode We generally write what's on them when we're filling them, because we fill these right in store. Where they're filled by weight. So, they have the shoulder labels, they have the DOT label. This is about ready for a new one. Knock you out there, buddy. Got a good thing. They have 4 different valves that we're using here, and you guys would use all 4 of them at one point, sure. If you're using the 230, 22, probably not. This one. Safeties and valves. So. We've got. A gas use. Each valve has a purpose. So if we want to pull gas off it, we'll make sure we use the gas valve. We've got a liquid side. Liquid. Which a lot of the labs around here are just using. A hose. With the nitrogen diffuser on the end of it. And a lot of problems we run into, a lot of what we see, we'll get back tanks that have on the liquid side. Red stripped out. Stainless steel, brass. So you gotta really be careful. When screwing these on. And yes, I'm sure we deliver tanks that have had. More valves and more nipples, so. It happens, there's an issue, let us know, we'll get taken care of ASAP. But be very careful when you're screwing on the liquid side of these. On the other side, we've got the last valve is what we consider the pressure building valve, which is right here. So normally the function of these cylinders is we've got 13 cylinders worth of liquid here versus gas over here. So if we're using 20-some bottles or we need liquid, we'll get one of these tanks in. If we need a certain pressure over 22 psi, we'll get a 230. But we need pressure. We gotta get pressure off the dewar. We need it. So this has a pressure building valve. And in order to build the pressure up, which would do naturally, we'll open this up. It cycles the nitrogen through coils on the inside of the tank, which will boil the liquid off faster and make more gas for us.
And which you can see right here, these are the coils coming up through there. If you turn that pressure builder on, they'll turn a frost,
You'll get frost.
and then you know that it's building pressure on the inside.
And that's another thing, questions about or concerns about is, well, I've got frost on the outside of my door, what do I do? Or my dewar is hissing away, well, it's designed to, we've got liquid into here, liquid argon in here, it's constantly boiling off and building pressure. So we have to have some way, we have to have some safety in place to, not, so we have safety. The safety right here, it's designed for leak gas, it's designed to vent gas off, so over time, as these dewars sit, they're constantly building pressure, so they're gonna leak gas off. Especially if you leave a pressure builder on, you'll hear it, and you'll hear it, like really, if the pressure builder's on, so you're just wasting gas. But also, if we're wasting gas, we have to really think about where is this dewar sitting? Some of the places we are told to put dewars on campus are kind of fishy. Some of them want to closets because all they want to do is put nitrogen. Well, that's not safe. Why would you put one of these in a closet and you're constantly leaking gas on? So, and all you're doing is pull nitrogen off on a 22 psi, so this thing's gonna constantly, it's not constantly, but it's gonna leak more.
On that, the question always comes up about elevators. What do you guys, when handling?
Our team supposed to be supply there. Because you, just in case it ever happens, you get your hand on an elevator, I used to work on campus. I know the elevators are not this, they aren't best. Even the freight. So yes, they are split to carry a pack on their back, and that's something to think about. And really, in reality, once we get this set in place, before you guys don't, we understand sometimes do. I have been a manure that was wheeled in between facilities, across campus here a while back, and I wasn't very happy with that. That is not safe at all.
Can a lab call you if they need to move one of these and you guys will move it safely?
Yes. Why they come out? We can't come out that same day. We're on campus on Thursdays, every Thursday. We was involved. We need to move cylinder, more than one cylinder. It's safer for us to come to it rather than you guys do it. So if there's anything like that, sure, we'll come do it. So, but yeah, moving cylinders in between facilities, I mean, sure, they're in your possession, but I mean, we would rather not do that, just because of safety reasons. Because one of these things gets knocked over pole, it takes 2 to 3 people or a crane to do it and lift it correctly. And I have had to come out in case say where it does happen when we're offloading these off our trucks. We do have to roll them down and we fold in ramp, and it is fairly steep, and they can get jerky and there are maps goes and they go, and there's nothing you can do.
Have you ever witnessed or been there after the fact for overpressure or the safety relief going, or just any stories you can share?
The 22 PSI, the 230s aren't so bad. We have the 550 PSI, which is laser still, which we basically will use on industrial lasers, on smaller industrial lasers. And when a 550 PSI goes off, PSI safety goes off, it's loud. I mean, it is like, it will scare the crap out of you. I'm not joking. We had a guy that was leaning on one camera one time, and it went off, and he ran. It scared the living Jesus out of him. So when these safeties go off on 230 and 22, they can be loud. They can be loud.
Also, safety at work, safety at home. I got my grill gas, and I put that in my small vehicle. Any comments on at home?
Carrying explosives in your car, or
Yeah. I mean, people got grills, right?
Supposed to be carried in the back of a truck.
not in an enclosed vehicle. If you come down to the store, we have examples of people that carry that have carried small acetylene cylinders in the trunk or in the cabin of their vehicle.
Mhm.
And they're unrecognizable when they go off, and it doesn't take anything to go off.
Wasn't it back east? That guy brought it in that new Beamer
I was in Nebraska.
in Nebraska.
Yeah, we had a guy burn his vehicle down right in front of one of our stores.
An acetylene in the trunk, went in and told them what they needed. They came back out, he hit the fob and blew up the trunk, the car, brand new car from a dealership.
Safety at work, safety at home. Thank you.
We have policy maps, and if you bring out CD and we see what big we pull it out of, you're gonna turn around, you're gonna leave, and we'll keep the cylinder, you come back with something that we can put the cylinder in. That's awesome. We don't mess around when it comes to safety, because I mean, we get examples hanging right under our desk. We're not necessarily idiots, they just don't really know. I mean, it's just place to it.
Is your overpressure set up so that somebody can screw anything onto it? Because there was that case, what was it, down in Texas several years ago, maybe 10 years ago at this point, where they basically had a tank probably about that size, and it overpressured, it just blew up catastrophically, and it took out that lab and the one above and below it.
On a tank this size, these safeties all are. They are. So if you screw something on there, that's on you. They're designed not to be tampered with. We aren't gonna be liable for something like that, I tell you that right now.
I think the theory was that somebody was tired of the hiss and
Yeah.
tired of leaking, paying for the nitrogen and it constantly leaking out.
That's when it becomes.
So you see. Periodic. System, safety valve. do they get kind of frozen open sometimes?
There'll be an ice crystal.
We fill these tanks the day before we deliver.
So if that happens, what is the best? I mean, I know how I've been told to deal with it, but I want to make sure that's correct. Like,
Yeah, you just tap on it and it'll knock that ice crystal out and then it'll reseal.
so
Yeah, should seat back up.
I would maybe never, or maybe I've had one not.
Right.
These cylinders are full, especially after we just filled them. There's no headspace inside of here. So it's gonna pressure up a lot. It's easy for the pressure to build up, so the safety is gonna go up. So as that headspace grows, and that tank goes off, it's gonna have a harder time heating, pressuring off. That's another thing. When it's hotter than heck out, these things are gonna constantly. You'll find it. I mean, luckily we sell to Kansas State cheap enough. I'm not lying, super cheap. And during the heat season, you'll lose basically 1 to 2 cylinders of gas out of here just from the heat. So that's just part of the monster. So
Are there considerations going along with that if an air conditioner goes out in a building or a lab? Like, is there a certain time frame where that would be a concern, or is it regulated?
no, it's never gonna. I mean, it's gonna purge, but I mean, it's really gotta be. It's just, I mean, it's just something to be mindful of and not complacent about. If you're in a lab and you hear a little hissing noise, especially if you're in what's considered to be a confined space, and you know, a closet or something where there's a doer, I still think it's smart to be putting them in there. So, yeah, they do this a little bit. If all you're doing is pulling liquid off, maybe you don't need a 22, maybe you can go to 230. And it's not gonna leak off near as much, and you can still pull liquid off of it, no problem. It's just the gas that's gonna be pressured at 230 PSI.
And you guys that have the doers, you'll see a blue and a yellow tag.
Yeah.
So I've got dual pressure tanks and single pressure tanks. So it's got a valve on it, which will turn it from a 22 PSI to a 230 PSI. And so that way you can change that there if you want to keep it from hissing.
So lastly, everybody's favorite friend, PPE in the lab. Obviously, safety glasses. Anytime we're messing with, you didn't bring the sleeves, you fired. Anytime we're filling these cylinders, we're wearing safety glasses. We've got a clear shield. Any form of heavy leather gloves, and they don't have to be a cryogenic gloves. Heavy leather with a little bit of insulation will work, no problem. Sleeves, if you don't have sleeves, you want to have some sort of cotton sleeve on. In the winter, they're nice to have on. In the summer, they're kind of hot to have on, but when you're working around these valves, especially when we're filling, there's a lot of ice. There's a lot of vapor. When we fill, basically, we're filling these, we open a liquid valve and we open vent valve to fill. So a lot of times we'll blow vapor out one end and we'll put liquid in one end. So I mean, it'll look like a nitrogen bomb went off more film. It's nice and cool in the summer, but it's cold in the winter. So we're wearing sleeves, cotton sleeves that have elastic on each end. We're wearing leather shoes. I'm not necessarily saying you in labs, you guys need to have steel toe boots, but we have a requirement with our drivers and anybody that handles cylinders in our facilities that they wear a full metatarsal. Because yes, cylinders fall over, and yes, they do in your feet, and it hurts. So
For the safety sleeves, is it acceptable for people to put on a lab coat when they're?
I'd say you're just wanting to protect yourself from vapor and an accidental touch. Just an accidental touch to a frosted line will blister you. I've been burned by nitrogen multiple times, so it's just running up, the sleeve drops down a little bit, you got some skin showing on the backside and you brush up, ow, yeah, it hurts. So yeah, we recommend face, arms, gloves, and then footwear, leather, because anything, tennis shoes, liquid nitrogen is gonna go right through that, and that's not gonna feel good, so. PPE, we hate it, but we live with it, it's a necessary evil. I think that's about it. Questions, complaints, you know where the complaint department's at. Sorry if I ran long.
If we have. That's not needed anymore, you work for like the recycling or reuse
We're talking.
thing, well, any amount, let's just say that, from, yeah, from lecture bottle all the way up to giant tanks.
Yeah, I mean, I can come up and we can take a look and see what we can and can't take. And then we.
If it's a bottle like this or a bottle like that, and you're not sure where it came from, that's fine. Lecture bottles are a whole nother animal. There may be an instance where we could get taken care of, but I mean, I've got an expert I'm working with, he's got a pretty good idea, actually, I have a couple of guys. Last visit we had, they've got, talked about some lecture bottles on campus that have been here for a while that we were looking at getting rid of, but yeah, we can definitely take a look at them, that's not a problem.
So. Anyway, it didn't have a sticker, you missed it, pick it up, we ended up taking it outside and venting it, so it's empty. But then can that metal cylinder just be recycled or put it into you guys, or what, like, how do we deal with the cylinder itself?
Yeah, I wouldn't even bend it outside. I would just see, I can come up and look at it and see if we can take it. And
I
then.
mean,
we-
it's empty.
So we can't do, that's the thing, if it doesn't have that shoulder label, like we talked about, the DO2 label. Over here.
Right.
we have an issue.
I don't think it does, I don't know.
What size was
I can
it?
come up and look at it, Marla.
It's about the size of an oxygen E-tank, but it's not a different.
Is that the one that sits in that lab in the store area?
Yeah, and we've emptied it, like, we know there's no gas in it, and we wouldn't have done that except that it was CO2 and oxygen, so I wasn't worried about safety of going outside and letting it empty itself, right? It wasn't something toxic, but now I'm like, okay, if I take it and put that in the recycle thing up on the hill, I don't want somebody to think they're gonna get their head blown off if the valve breaks off that, like, what do I do with the metal itself?
Yeah, we need to valve out. 100% empty the valve. To recycle, they have to have the valve out.
Okay,
That's the biggest thing. That's how we recycle is a valve has.
okay,
Yeah, if you've got no gauge pressure, if that's where you're going on gauge works, then we can reclaim it, yeah.
Atmospheric pressure in there, that's fine.
We've always gone on the rule of thumb that you've got to be able to demonstrate that the body's empty, the bottle is empty. And to do that, either there's a hole in it, obvious hole in it, or the gauge is the valve is all the way out. So you can just look at it and go, that's an empty bottle, we have no pressure in it. Because there are instances of CO2 fire extinguishers getting thrown away full. There was one where they took the jaws at a recycling plant and it punctured it and it ended up in somebody's roof on the next property. And that's just about a 10-pound CO2 fire extinguisher. So you have to demonstrate that there is no way there's pressure in that.
Person. So do we have any regulation to secure oxygen and acetylene cylinder, the flammables and oxidizers? How far should be there if the
So
lead is
there's a couple different regulations that OSHA has. On storage of oxygen acetylene. If the bottles are in storage, the valves are on them. They can be in a, it can be in a rack, but there has to be a burn wall rated at 3 hours, I believe,
Okay,
or 50 feet. But if they're in use, together is fine.
okay.
And as long as they're chained together, as long as they're chained.
So,
Some carts have firewalls.
and so if we have questions like that, just kind of typical code questions, you guys have information, such as that on your website, or would it be just best?
You
to
can just
give you,
Get a hold of him or you
I was wondering if it just maybe talks about the services.
Off the web and coming up here and talking just from what I know.
Yeah.
So I mean, I could give you resources, design resources. It's more, skip or we're talking, man, if I'm not speaking, talking about. I travel. Right.
What about wanting to store these on the exterior of the building? Does the code just talk about protecting those from the elements or?
The only thing I worry about ever storing any kind of cylinder outside is maybe an acetylene cylinder, and it's gotta get pretty hot to do anything from a acetylene cylinder, and I mean hot. So, no, we prefer it. I prefer, my drivers prefer it. If we can just back right up to a rack that's outside or, covered storage that's outside, there's no problem. There's no issues with that. I mean, obviously oxyacetylene, we want that burn wall in between cylinders that are in a rack together, or we still want that 50 feet, but. I mean, that's just, like a shop, they just put in oxygen on one side and cylinder on the other. Lab's gonna be, for case they might be a little bit different.
At the end of the day, we'd rather have our bulk, our tank farms, everything outside or in an adjoining room. But for servicing and even the heat, the temperature differential, it's best to put a roof on it and protect your equipment as well. Running it through the wall is not a big deal. There's all kinds of great devices, but it goes back to how much do you also have in pressure with the manifold and how many is in the rack and I know we didn't cover it today, but if you actually look at the pounds and release the atmosphere, how many cubic feet that is, people go, oh, wow, that's my entire lab. So, going back to also having the alarms in there in case you do have a failure in the tubing or, the manifold or, however you get it situated, that's the big deal on the user side to turn that off, after use. Even though might be small PSI, you need to turn those on.
330 cubic feet in one of those bottles. So one of those leaks off in your room and you'll know it.
Just something to add on what I mentioned earlier. Don't try to take those valves off yourself. Take them to some place like this. They'll have the proper equipment. Because those things, you really, really need the right equipment to get those valves on. They may not even come off unless you have the proper setup.
Quite honest. Quite honest.
I can
just be able to snap them off.
I can get labels, if I know, say it's an 85.55 or something like that, I can get a hold of our spec gas guys up north and they will send me a label that I can write those percentages in. So we can put that label on the cylinder for you to get rid of it.
It's better for us, so that you can.
What if I
You
don't,
wouldn't need to mess with the valves.
if it's a lecture bottle and I don't have a cap?
So electric bottle was electric bottle different. Technically, if you get an electric bottle change the card, you probably didn't get it from this. But I have a company that I work with that I'm working with probably to bring them on campus here eventually. That deals with lecture bottles and lecture gases. Technically, once that bottle's in your possession, it's to deal with, and they are considered scrap bottles. Depending on what was in it.
So.
Price of, when you get a lecture bottle, the price is, the tank's included in that price.
But the valve. I'm assuming this is.
I don't think we can.
Yeah.
Campus, we can sit down with. And look at the electrical you guys have.
Yeah, and I think for everybody in the room, and everybody listening though, if you've got specs, just list those down. We'll list those out and bring our Matheson's guys back in and we'll hit the campus. So compressed bottles of concern, lab setups, et cetera. We can do a laundry list, and for those listening, just send us an email. We'll gather those areas of concern, I guess, and look at them more closely.
What's the proper?
Lagged into the, have your facilities guys put lags in the wall, and then you run a chain around it.
Sorry, we're gonna have to go to our website.
Do we, big cylinders?
So here's some examples.
In
Some buildings built from them.
We don't. So she's anything.
This is the wall type. Where he mentioned you would lag into the wall, and then you've got a strap here. With a special clip that will hold your place. This is a. Bench type. Where you tighten it down to the bench. And then your lecture bottle holder. So those are some types. There's other types out there. There's other brands out there. Those are just the ones we sell. Don't pay attention to the price. That's stupid.
So how are two eye bolts and a chain, which means not. That okay?
You guys secure it to the wall.
Is there a kind of a height
These-
of the chain?
Stay halfway up the cylinder.
Yeah, they have big amount. Not being able to be tipped over.
Yeah, and I know our maintenance guys or whomever may put a lag bolt into a 2x4 or whatever. But at the end of the day, what I tell them, if the strap or the chain is not tight, that's why we also tight it. I don't want to test the specifications for your lag bolt and get that extra weight into it. So that's why we always say, hey, that chain can't be any lower. It's really, even though it's around the cylinder,
Yeah.
it's really not going to keep it from falling over. So I think that's where you're going, right?
Yeah.
Keep them tight, keep them nice and snug.
When we transfer cylinders on our trucks. We have two straps.
Something else I saw said not to use straps. Because they can burn.
I see.
It could be a chain instead of a
I mean,
strap.
we use straps. We know the straps aren't gonna break. We inspect our straps. As far as them burning,
What do you
they're
use?
nylon.
Well,
and it's-
going back to what do you use, but all the straps, like when EH&S will look at your lab or your setup, we want substantial webbing. We want sturdy webbing. Also, I've seen in the past where it's like, my 10-pound dog will break that chain, but it's chain, right? So going back to the specifications piece of it, I want sturdy, substantial webbing straps. I've never heard of the two, for in lab, as long as you got it nice and tight and secure. I've not really heard ocean enforcement or
No,
regulatory.
it's Matheson standard. Because obviously we're transferring cylinders, we've got cylinders, we're bays of 12 to 18 cylinders. And that's a lot of weight that we're securing. Would one strap cut it? Sure, I used to do 20 cylinder bays with one strap.
Yeah, and going back to though, that's another, I get 10 of them and I put that same strap across there. And sometimes I take a few and it starts to get pretty weak, and then we're gonna go my following cylinder, and it is not gonna keep it in place. So I know that one chain, one strap idea we've used, but again, if it is not firmly around those and I can actually push them one way or the other, then we ask you to get more chain or more strap, because one is not gonna serve both.
There is another option, if you have a number of cylinders that are all chained together. Or together in a group, or they're against the wall, and you want to be secure with your chain and you want to be secure with your strap. Is when you group the cylinders up, and when our drivers should be too, they should be, every cylinder should have 3 points of contact with another cylinder. Kind of like you take like if you go bowling and your pins are set up in that triangle, but you can push it all together. Those cylinders, if they make 3 points of contact, they're less likely to fall over. And then when you put that chain around it, you're even more secure. So you could run into, I'm not saying I've ever done this, but you could take a forklift and just kind of nudge a bay of cylinders that aren't strapped, but they have 3 points of contact. They might rock a little bit, but most likely they're not going to fall over. So 3 points of contact is a huge one to remember, as well as your chain. So
Support from each side, I think.
yeah, so you've got 3 round cylinders combined together, and each cylinder is touching each other. It's got 3 points of contact, basically.
So maybe a cylinder on each side and then one side against a wall. Chained on that side.
You got 3 points of contact.
So if we are grouping the cylinders, is there any regulations on the height of the cylinder? Because if we have only one strap and one is really small Lilliputian, it will miss.
Yeah.
That's when you two straps, because if you have a shorter cylinder and a taller cylinder, okay, maybe my chain's only gonna hit that, and my shorter cylinder is just chilling there. It's you're in danger. So that's when you look at two chains and 2 straps.
Okay.
So revisiting back with webbing, then does it need to be fireproof webbing so that so should there be a fire that our firefighters aren't in risk of these things launching into them? Is that
I've not looked deep into fire code, or Jack, maybe we could take that offline, but the webbing, you just saw the one for the countertop. Usually there's a webbing, and the reason is you can get a nice tight, secure it really well. But we'll look behind the scenes, see if we know of anything unusual, but I haven't heard of it.
Yeah, and maybe if the webbing is fireproof, this is just more thinking down going down the rabbit hole. You'd sure hate for your firefighters to show up and the thing flicks over and launches through them. Just a thought.
Where they're being stored.
When we first deliver to a new account or an existing account, or we have a new driver that is hired on, we have to do what's called a site survey. They should be doing a site survey. If there's anything that concerns them about the delivery, they can do a site survey and then turn it in. A lot of drivers, they are really familiar with, this is probably a good idea. Train them how to handle the cylinders and what to do with the truck.
Actually place them where they're supposed to go, or how does delivering it secured still?
That's a touchy one, because we want our drivers. If we, especially on 140 cylinders a day, and then all the 12 doers, we prefer to have one central point where we. Some locations don't will be ours, some locations will be ours. The doers, we will do a delivery to where they need to be. That's just because obviously we don't really much that because they are super headers.
There's 2 places up on campus that they move their own gas packs that's different. Oh, really? Yeah, okay. They've got one in there.
Yeah.
What's that?
CBC.
So where we have changed downstairs. But you didn't like it, yeah, you would speak up and say, because
I think there's a vent up on outside in that room. And go that door, I think it's a vent. I think that's how that one's supposed to, because there's a vent that vents outside.
I think most of the sites on campus. Very good. And, some empty. They used to have. Site for very long.
You guys
Beyond.
can sell the,
Yeah. So.
Yeah.
guys on installation of them.
We. Very.
Bill does some installation for us on several different things.
When it comes to gas detection systems, we've got our own brand. And then I think the main brand we work with is RKI. We have a rep out of Kansas City, and it's something where we can do something as simple as lab. Or we can turn into a full building. So that's how far the gas detection.
Got it.
And we could do that when we might like to have, alarm and an audible and a visual, just. So something on the outside of the room that's flashing or alarm inside the room, so don't come in here.
I don't think that UC Berkeley says to use a non-combustible material. That's what they're putting for their restraints. So non-combustible.
Yeah. Chain.
Jane is.
Or strap.
You could have seen that advertised.
I have never heard of it.
Yeah.
Never heard of it.
Okay, so K-Staters, let's start patenting some safety equipment.
There you go. You can resell for K Matheson if you want.
There you go.
Anything else?
Good stuff.
All right. Well, thank you for your time, guys. Appreciate it.
Thank you.
Hopefully we learned something.
Thank you. For you, K-State. Thank you.
See, take it.
Make the redneck ice
Oh,
cream
really?
scoop, except that's made at K-State.
Thank you.
Thank you, guys. And if anybody had any questions or even comments after this, just, email us, let us know. Also, too, another housekeeping item, Rachel.
Even fire.
Like everything. Yeah, it's like they're curious. Now, they. But it's sure.